negativity. Now this lady here is chlorine. She's what? Chlorine. Chlorine is more electronegative, right? Yes. Of course, no chlorine, oxygen, and nitrogen are what? Electronegative. So this lady now is coming now. She has displaced all the hydrogen in these guys. You know butane has how many hydrogen? Butane has how many hydrogen atoms? 10. Butane has 4 carbon, 10. Now this lady has displaced one of the what? Hydrogen atoms. And she has bonded to this 4 carbon. Only. Now listen. Because she is powerful. She becomes partially negative. When this guy becomes partially positive. Is that okay? Now because this guy has less electrons, I mean now come out from this guy. I get me? This one is now somehow less of electrons. This guy pulls more from this. So this trend down a ring is called inductive effect. It's called what? Inductive effect. Now why the bond between this guy and this guy? Because this lady is more negative, she's taking all the electrons. If you look at it, there's an arrow pointing towards a direction. She's taking the direction of the electron movement. So this bond now becomes what? Polar. Ordinarily, carbon is what? Non-polar bond. I get me? But due to the electronegative difference in these two atoms, this lady coming in make this copper what? Polar. As if she's oxygen now, she has changed the chemical reaction of this compound. Yes. Ordinarily, what is it called? The reactions that butane will not undergo, if it carries oxygen or chlorine now, the reaction changes. Chlorine is a good living group. Are you understanding me now? If water attacks now, the chlorine can go off and it becomes OH. You now have what? Butanol. So the kind of bonds, in these various compounds determine the kind of reactions they undergo. So by when I come next time, I'll be teaching what they call carbonyl groups. And they either ketones. You will see that the kind of bond between carbon and oxygen in carbonyl compounds, which is double bond O, changes the reaction of that compound. It affects the reaction and says so much about it. Is that okay? Yes. So, when you see a compound, you study the kind of bonds in it. Study how they are connected. You tell the kind of reactions they can follow. Because this semester, K124 is more of functional groups. First semester, we are teaching you valency electron theory. We taught you this reductive effect, right? We taught you organic chemistry, alkanes, and so on, petrochemistry. So now, we are going to the various functional groups now. Okay? We've taught it lower one, which is alkane, and alkane. So now we're going into what? Esters, carboxylic acid, and so on. Is that okay? So do you understand it now? So when you say inductive effect, polarity, and what they call dipole moments. Of course, the higher dipole moments, the what? The greater the what? The polarity. And of course, polarity in chemistry, you are told that light dissolve light. True or false? Yes. For instance, water cannot dissolve kerosene. Why? Because kerosene is, what is it called? Hydrocarbons, which is what? Non-polar. While water is what? Polar. So water can never dissolve what? Kerosene. They don't mix. They don't what? After you shake the bottle together, once you mix, what happens? Everybody find their way, they separate. According to what? Densities. But you see kerosene and water dissolve. You see oil and soap. You know soap? Soap, we will get there. Soap is a fatty acid. It's a fatty, soap is what? Sort of long chain carboxylic acid, which are called fatty acid. Now, long chain carboxylic acid, the long chain of the hydrocarbons is non-polar. While the carboxylic end of that soap is what? Polar. What your soap does is, your soap connects the non-polar end of the non-polar end. And then the polar ends connect the water, non-polar ends connect the what? Oil. So at the end, it dissolves the two together. That's why when you mix water and kerosene, you don't mix. But once you add what happens, the kerosene dissolves in the water. True or false? Because the soap connects the two together. The soap does what? The hydrocarbon end of the soap picks the oil, while the polar end of the soap picks the what? The water. So at the end, it connects together. So you can see chemistry are going to resolving issues, right? Thank you very much.